Okay, I hope you have seen our last video, and if you not, then you should see that last videos so that you can continue this video. So in this video we are mainly going to discuss this SN2 and SN1 reactions. That is the very most important. This is most important portion that is about to come out in examination, and it is very easy. Now SN2 stands for nucleophilic substitution bimolecular. Okay, S and N stands for nucleophilic and S stands for substitution. Now we should know what the substitution means. Substitution, there's two words, substitution and elimination. So you just focus it that there's a substitution, a word is substitution and elimination, these two words. So these two words in daily life we can focus on. That substitution, that means that on the very that you entered in the class and at the very first seat there's somebody already. So what you did, you moved there and replaced that candidate. Okay, this is you and this is the previous one candidate. So replace that candidate and you are now at that position. That means you acquired that position and you substitute him, that you removed him away. Okay, in the elimination there's somebody again in that condition, is somebody on the very first seat and you entered in the class, but what you did, you removed him from the seat and you also didn't seated at that seat. Okay, so there's vacant that place. Okay, so this is the elimination condition. So here we are discussing the substitution. In substitution, this is what is going to happen, that this chloride is going to be substituted by some nucleophile. So first you should know what is the nucleophile and what is the electrophile. In very first, I know you already know, but in very easy tricks, there's some trick that you have to know, that this is made up of two words, the electrophile and nucleophile. That means phile means loving. Always know that phile means loving, that means it needs that, and nucleo means it loves nucleus. Okay, and in electro, that means it loves electron. Okay, now this is nucleus loving. At nucleus there's a positive charge. Okay, so it is nucleus loving, so it loves nucleus. Who loves nucleus? Some opposite charge, that means electron. So electron that have any compound that have negative charge like Cl minus, OH minus, these are the nucleophile. And any compound that have plus charge like H plus, Cl plus, okay, these compounds are the electrophile, because they loves electron, they are in the lack of the electron, so they loves electron. Now this is the nucleophilic substitution. So nucleophile are going to be substituted away, so chlorine is going to be substituted away. So very important, this is the case of inversion. In this compound the inversion takes place. Why? This is the single step process, there's no two step, this is a single step process, and this is the intermediate. You can see here OH minus is about to attack and it attacks at this position. So at this position the intermediate is that there's little bond of the OH with this carbon, and there's, due to formation of this carbon, this little bond, this bond is little bit weaker. Okay, so this goes to be much weaker, and at the ultimate this OH acquires this group and Cl minus is removed away. So you can see here, if the umbrella is at first pointing this side, so at the end of this session this is pointing our reverse side. So this is the case of inversion. It is very important. This is the inversion configuration. Okay, you can see here that which type of group prefers this SN2 reaction. This is SN2 reaction, which type of group prefers. So the priority chart we are going to discuss right now, that the priority chart is primary, then secondary, then tertiary. That means primary halides react faster SN2, then secondary, then tertiary. Why? Because if the primary, it is primary, so these are the only hydrogen groups, so these are the very small groups. So the attacking, there's the site, means which it can see hydrogen, means hydroxide group ion is looking at the distance, it is getting a more space to attack, so it attacks at this position. Because of these small groups, it can easily facilitates at this location and it attacks on this position. But if assume that it is tertiary, so these must be some bulky group like alkyl group, these three are, so there's very little passage to that's a little canal to enter for the OH minus at this location, so that third tertiary compounds don't prefer this SN2 reaction and primary do. And at the second step, we are going to discuss the substitution nucleophile unimolecular. That means SN1. In SN1 reaction, what happens? This is the two-step process. Very important. It is a two-step process. Okay. You should know two-step process. Why? At the very first position, the carbo. This is the first step. At very first step, the carbocation produces, and at the very second step, what happens? The carbocation reacts with this compound, this OH minus, which is the reacting nucleophile, and forms the second group. So at the first step, you can see here, this is the compound, this and this bromine, and these are the alkyl group. That means this is the tertiary compound. Okay, so we all know this is going to break as the OH minus is approaching it. OH minus is approaching it, so this is going to break, and carbocations like this C, and cis, it is going to make at the very first step, and we know the tertiary carbocation is more stable than the secondary than the primary. So who prefers this reaction? Tertiary prefer more than secondary than primary because of the stability of the carbocations generated at the end of the very first step. So this is the very first step, and this is the second step. So reactivity order decide that in the SN1 tertiary SN1, in the SN1 the tertiary